Here's problem 14.6. A police crime lab is trying to determine whether someone was murdered or died as a result of an accident. He was struck in the temple by a 4.2 kilogram sculpture that is alleged to have fallen off a bookcase. The sculpture presumably fell a distance of 1.43 meters, and the corner that struck him had an area of 0.25 square centimeters. If the time for the sculpture to stop was 1 millisecond, the pressure on his temple in newtons per meter squared was, alright, so we have a sculpture that fell and hit the poor guy. And the area of the sculpture is 0.25 square centimeters, which would be 0.25 times 10 to the minus 4 square meters. And it fell a distance of h equal to 1.43 meters. So the velocity it had when it reached the person was equal to the square root of 2gh, which would be 2 times 9.8 times 1.43 square root, and that is equal to 5.29 meters per second. Hence, when it hits the fellow, it's going to change its momentum from this speed to 0. So the change in momentum, at least the magnitude of the change in momentum, is going to be equal to the mass times the magnitude of the change in velocity, which is going to be 4.2 kilograms. Final velocity 0, initial velocity 5.29. We want the magnitude of that, and that's going to be our change in momentum as he's hitting, which is 22.24 kilogram meters per second. That's the change in momentum. Hence the force, the average force felt by the temple, is going to be equal to the change in momentum over the change in time. And that's going to be 22.24 kilograms per meters per second over 1 millisecond, 10 to the minus 3 seconds. And that will be 2.24 or 2.22 times 10 to the 4 newtons. That will be the force on his temple, and since pressure will be equal to this average force per area, that's going to be equal to 2.22 times 10 to the 4 newtons, or the area of the temple, which is 0.25 times 10 to the minus 4 meters squared. So this is going to be equal to 8.89 times 10 to the 8 newtons per meter squared. So that will be the pressure on the temple of the poor guy's head, which would be about, since 10 to the 5 is the atmosphere, that would be 8,890 atmospheres. That'd be a lot of pressure. It's very possible that this object fell off the bookcase and it was just an accident that killed the poor fellow. So 8.89 times 10 to the 8 newtons per meter squared.